For the time being, it's going to be 2 of an x minus 1 equal lambda, and the 2 of a y minus 1 also equal lambda. From here, I will have x minus 1 equal lambda over 2, y minus 1 equal lambda over 2. This is plus 1 and that's plus 1. Now I have the values of x and y. I will take them and substitute in y plus x is equal to 1, from which I can get the value of lambda. I did exactly the same steps and sent you these slides. So the first, getting the gradient vector, equating them together, making the magic to happen. Now I knew that lambda is equal to -1, resubstituting by lambda equal to -1 in both these two equations, exactly the same. Will develop x is equal to half and y is equal to half. I know x and y. I will substitute in the objective function by 1/2, and then I will get the value of the optimization of my problem. It's very, very simple combination between solving these optimization problems either by the calculus or, as you can see, by the graphical solution. You need to use your hand. This is really very important. So once more, that's the final step. Now I know the minimum is going to be half. The last circle must pass by 0 and 0. If I put x is equal to 0, y is equal to 0, so the biggest value is going to equal to 2, and that's represent the maximization. Now I know the minimization and maximization points relative to my objective function. To more problems, that's another problem also. I've tried to solve most of the problems that my hand can reach. So this one is f of xy 2 minus 2y minus x, and you have the circle x squared y squared let them equal to 4. In a similar manner, I will try to draw first a quarter of a circle whose radius is equal to 2 and already exists in the first quadrant. I will try to solve x, this line, which is simply 2 minus 2 over y minus x equal to 0, which will lead to 2y equal to negative of x plus 2 divided on 2. So y is equal to negative half of an x plus 1. That's the line which I will draw when x is equal to 0, blah, 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 blah. Then I will try to see the direction of increasing and direction of decreasing. That's the points when getting the value of 0 and 0 and substituting on f, it's going to be 2. If I reach this point and substitute in f, if it was less than, it will be a minimizer or the minimization point. If it was greater than this value, it will be the optimization point. That's exactly what we did. F is 2 and 2, okay? And if we solve the problem getting the gradient vector of f, the gradient vector of g, equating them both together, in a similar manner, I will get the value of lambda. I will substitute in the condition, and so one of the solution will make sense, the other doesn't, because one of them is 2 over root 5, the other in negative 2 over root 5. This must be cancelled because I'm in the first quadrant. So the only permissible value is a positive value of x. X is 2 over root 5, substitute, it will give you y. Resubstitute by both of them, you will get the minimization problem the minimization value of f, as you can see. So mainly those are the main steps, as you can see, for optimizing my problem, either by increasing, getting the maximization, or getting the minimization. I've also solved more problems for the worksheet for this part of our lecture, like the optimization of 2 minus 2y minus x, let them equal x squared plus y squared equal let them equal to 4, and still we are in the first quadrant, as I told you. So simply all I have to do at the time being is to draw this function, which is x squared plus y squared at 2. Then trying to draw these lines. This is gonna be the maximum and the minimum point. Redo the steps once more. It's really very simple and in front of you. I want you to try them in home because mainly this is an AB. Within the first midterm, there will be a question, a complete question about this part. That's also another, the continuation using the calculus. I will get the gradient vector of both f and j, equating them both together exactly as we did. Then we will try to get the value of x, which is gonna be a 2 over root 5, and resubstitute in our problem, as you can see, getting the value of f. This is really a very important problem as a teacher. All of this are proposed exercises. I want you to try them by yourself, exactly the same. There is no problem whatsoever. That's the objective function subject to these constraints. Those are the constraints of the non-negativity, and also the main constraint that I will follow in order to determine the visible area of solution. Then try to draw the k-level curves, then get the intersection between them, and then you will be able to minimize, to get the calculus of your problem exactly the same. Okay, thank you very much. I will continue within the next lecture, inshallah. Thank you.